Assalamu alaikum, this is MATLAB lecture number 10. We will solve the second example, which is set of differential equations. In this example, we will use the simulink to solve these equations. The equations are x dot equal 1 minus x dot y dot equal 1, 0 as a column vector plus a matrix times xy. Our initial conditions are known: x of 0 equal y of 0 equal 0. The first step, we should select the way how we can solve this system of differential equations. We can design two simulink systems and solve them, one for x and one for y, or we can merge them in one variable, like say u. In this case, we should write the equation like the following. This xy, say that this is u. In this case, x dot y dot should be y dot. Say this is a constant vector and this is a matrix called A. In this case, as you see here, should be the y dot, u dot, sorry, u dot equals c plus a u, where c it is 1, 0 as a column vector and a it is this matrix. Now I will use the simulink to solve the system. I will go to in new. From new, I will select simulink model. As you see here, we should go to create a blank one. I will start from scratch. As you see here is the simulink window. Let me open the library first. We go to here, select the library. We can keep it like this to the left. Now we want to define the c constant and a constant, so we can go to source constant, drag and drop the constant value. We can write it here or double click on the block itself. I will write it directly here. It is 1 space 0, like this. Okay, this is the value of this constant. Click and you can resize the object like this. By the way, you can click on the name here, write C as a name. You can also Ctrl C, Ctrl V to copy the same constant, change the name here to A, and here double click. You can write the matrix, which is it is -2 space -5 semicolon to go to next line. Or next row, 1, 0. That's it. So now we have the matrix A and we have the constant C. Then we need as you see here, u dot equal c plus au. So we have to multiply a by u. A, it's a matrix constant. U, it is a signal, any signal called u, and the system we are designing here will solve the equation to find the value of u and the value of u containing x signal and y signal values. So we need multiplier or gain. It's up to you. You can use the gain like here or multiplier. I will choose the multiplier first and then I change it to gain. So I will go to math operations. From math operations, we will go to here. We have add, we have divide. Okay, I will select divide. And I will select the gain also. Keep it like here. I'll see in the divide here we have star and divide. We can make them 2 stars like this because I want to make multiplication. Okay, you can resize the object like this. Okay, now we need the A. Let me select the A here. So A, it is multiplied by the U. We don't know the value of U. Let me assume that the u it's just a constant. Let me go back to sources. From sources, I will bring a constant. I will assume that this is a u. Not this, no need to do that. But if you want to remember where is u exactly connected, just assume that this is u. So now this is a times u. Okay, here we have a warning here. If you see unrecognized function or variable. Because u is not defined yet. Don't worry about this message or this warning. Now it is as you see here, it is a times u plus c. So this is the c. We need the other. I will go to math again. from math operators, I will choose the add. You can size it again like this. Okay, I will connect this one to this side and connect this one to this side. Now it means A times U plus C. The signal come from here, guys. It should be, by logic, it should be the value of U dot. Now we can integrate the value of U dot to get the value of U. So this, after integration, we will get the U value. So how we can make the integration? And remember that for integration we need initial condition. The initial condition here for x and y equal to 0. We can say that it is U of 0 equal to 0. So let me solve it now. I will bring the integrator. So I will go to continuous functions. Here we have integration. I will connect from here to here. Just to remind myself, we can click here. We can write U dot or du. This is du over dt, the first derivative of u. It's supposed that after integration we have the u. Let me click here, see the initial condition is 0. When that means when the time equal to 0, the u value equal to 0. And remember that the u value here, it is a signal containing, or say that multi-signal, so it will contain the x and y value. Now as you see here, guys, the result from here, it should be the u. So we have u1 and u2 signals. This should be x and this should be y. I will show you in the workspace later on. So now after integration we have the value of u. Next step, how we can show the values of x and y. We have different things. Let me go to sinks. I will show you. It could be a scope like this. It could be display, if you want to display the maximum or the average or whatever. It could be, as example, an output. It could be sim out to save it on the workspace. So let me use the sim out like this. Okay. Now I will connect here to the scope. Remember that again, this should be the u right here. You to remind yourself. Before solving the problem. By the way, how can I connect the u to the sim out so we can save them, save the u value to the workspace? Control and press on the mouse here and connect it like this. That means the u connected to the scope and to the sim out. If you want to remind yourself, right here, double click here, it will show you the u value. Now before running the example, run the simulink system, remember that we don't have the u value, so I will delete it from here. Let me delete the bus, and the u value, it should be taken from here. So I will press Control, take from the mouse, connect back to here, and then you can resize it or make it like this, guys. Okay, double click here to show you that this is value of u. Actually, it's like a loop, for loop or while loop. So the simulink will run the simulink system from 0 to 10 seconds. By the way, the simulation time here is just 10 seconds. We can go to preferences here and change the time, or from here change the some settings for this simulation. As you see here, the start time, it is 0. It could be -10 if you wish, or 5 or 10 or whatever. Stop time, we have here solver selection fixed or variable, keep it by default like this. And the solver, you have many solvers here, and there are many options that you can change. Okay, or just double click here, right from 0 to 100 seconds or 10 seconds or 50. It's up to you. Now it's supposed that our system is complete. Here, because here we have x and y, two signals in one, I think we have to take care about the multiplication here. As you see here in the multiplication, element by element, element wise, I think it's better to choose the matrix. Let me show you the difference. Save it. I will save it as a MATLAB simulink file. I'm waiting the MATLAB. Now you can choose lecture number 10, exercise number 2, lecture 10, example number 2.slx simulink MATLAB. Yes, never mind. Now it's saving, the MATLAB saving. Don't worry about the gain, I will use it later, but not connected yet, so it's okay. Now it's ready. Where is the result? We should see something in the workspace under the name sim out, and here we have the say that the scope. Double click on the scope. I'm waiting the scope to open now. We don't have any result. Why? I will show you later. I will run again. Now it's combining. Before I think it didn't run. Now view 2 errors here. See, we have 2 errors here. I'll see these are the errors. See, input of port number 1 lecture gain is not connected. This is okay. This is okay. And here gain is not connected. It's okay. Divide. We have a problem here in the divide here. This is the multiplication. Then the block name is divide. I'll see not known here because we have here LC matrix, and this is should be matrix multiplication. The concept here, it is matrix multiplication, not element by element multiplication. So we have to go to here, not element wise, change it to matrix. Apply, cancel, save, and then run again. Run again, the message will disappear now. We don't have this message. Maybe just that this one it's not used. Never mind. Okay. Double click, sorry for that. Double click here. I'm waiting. See, this is the result. As you see, it is not smooth here because the step it's very small. We can change the step, make it smaller to make more accurate graph. As you see here, we have 2 signals in one. The yellow one it's the x value, and the blue one it is the say that the second signal, which is y. Now, how can I make or draw or make legend here? We can go to view, select legend. I'm waiting the MATLAB. Yes, see how I know that the yellow one it's the x. It's the first signal in u.1 I see, and the blue one u.2. You can double click here, change the name if you wish. Here, change it to x. Click outside. I'm waiting the MATLAB to update. Click here, double click here again, change this one to y, click outside. If not shown again, view legend again, close it. Okay, open it again. Still click here to show the other signal. You can click here to hide one of them. Also, you can go to view configuration properties. You can indicate how many inputs port you want. Here we have just one input port. The layout, how you want the layout if you have more than one. See that 2 by 1, 1 by 2, sorry, like this. But we don't have another signal here until now. We will go back to view configuration, the layout, get it back to 1 by 1 and keep it like this. Now, how can I split them in 2 signals and show 2 signals individually in the scope? We can go to view again, configuration, make number of input ports 2. Apply. Okay. Here we have 2 signals, but where's the second signal? I will delete this bus, guys. Then I will choose a tool that will separate x and y. So we have to go to a commonly used, see here we have dmax. So I will connect this one here to the dmax control, like this. Now it will split them in 2 signals. The first one x and second one is the y, like this. Save, run. I'm waiting the MATLAB. Double click on the scope now. I'll see here we have just one graph. We have to go to view, configuration properties. It is number of inputs 2, but the layout, see that we need 2 by 1, 2 by 1 like this. Okay. See, this is x and this is y. You can go to view, and here we can say that change some properties, configuration properties. We can go to time, display, and so on. We can go to simulation, run it, stepping option, enable stepping back, and so many options. Now, what about the sim out? The sim out, as you see, the name, variable name, it is sim out. You can keep it sim out or say that this is you if you wish, like this. Apply. Okay. Now let me save the simulink, run the simulink, and let me show you what will be on the workspace. See, this is out. Open the out. Inside the out here, we have the u. Double click on the u. See, we have the time and the data number 1, data number 2. Data number 1 represent x value, and data number 2 represent the y value. So we can take them to another script file and run that script to solve or to plot or do some analysis. So in this case, they will be available in the workspace. You can use them directly from the workspace. Now, how can I use the gain? Let me go back to the system. As you see here, we have a times u. A times u. I will assume that in this case I will, as you see here, I will remove the multiplication here. I will remove this bus. I will remove this bus and this bus. I will bring the gain. Sorry for that. I will bring the gain to here. Connect the gain from here to here, so that connect back the u signal from here to here. It should be a times, as you see, it should be a times u. Double click here to show the signal. It is u, and again it should be the same matrix. So let me double click here, take the matrix, Control C. Double click here, Control V as the gain. And same thing, multiplication not should be element wise, it should be matrix. Now the matrix, the constant times the u. So k times u. Apply like this. Remove this k, this a matrix, and save them like this. Now this means u times this gain, the value of the gain. This is the value, which is the value of a. Okay, plus c give you the u dot, integrate the u dot, give you the u. Now it is okay to keep it like this, but I think it should be more professional than this. So what I will do, I will delete this bus, I will delete this bus, right click on the gain, go to flip, rotate and flip, say that like this. Okay, it is more professional. Now take the signal u from here, connect it to here, and then connect it back to here. This is better. This is more professional than the previous one. Like this. Save, run. Double click to see the scope. By the way, what will happen if we change the time to 50? No problem. It will show you the simulation from 0 time to 50, from 0 seconds to 50 seconds. I'll see like this. This is the value of x. This is the value of y. So the value of y, the steady state value, it is 0.2, and the steady state value of the x, it will be 0. Anyway, regardless this system what it is, this is the solution of the simulink. Now let me solve the classwork or the exercise we have here. For this exercise, it is well-known problem in mechanical systems, where we have here a motor connected, there is a circuit, control circuit for the motor connected to a load. So we have here inertia of the load and inertia of the motor. If you add the inertia of the load and inertia to the motor, it will be I value, as you see here. Here we have resistance RA, and here we have LA, and the current passing through this and the motor, it's I. And the voltage difference between this point and this point, it is VA, it's input voltage. So if we apply the voltage, the current should go through the system to the motor, and then motor will rotate and transfer the power to the load. we have actually to solve this system to find the relation between the current and the say that rotational speed W. So regardless how we can solve the system, these are the equations. As you see here, these are the equations. So we have VA, the input voltage, VA, equal LA times first derivative of the current with time, plus the resistance times I plus KE theta dot. Actually, guys, here VA should be entered by user, or it's not should be known. Say that LA should be known also. The I value should be known also, and here we have the resistance RA should be known also. LA should be known also. They are constants. B, the damping ratio, should be known also, and the torque load should be known also. So we have 7 unknowns here, 7 unknowns or constants. Sorry, not unknowns, I'm sorry. 7 knowns, the constants. Actually, we want to find the theta or theta dot. What's the theta value or theta dot? Okay, and what's the current value and the relation between them. So we have to solve the differential equations to find all of these. We can assume that when time equals 0, the current I of 0 equals 0, and theta of 0 equal to 0. Now, how we can solve them? We should write the equation in a good way, so we can represent the system. So let me take the first equation. This is equation number 1. And this is equation number 2. For number 1, write it, we can choose di, so we can write di over dt equal to, in this case it will be minus ra theta, sorry, minus ra current, not theta, I minus ke theta dot, and here also plus VA, all of them divided by the LA. Okay, now for the second equation, let's say that we'll take the second order, second derivative of the theta dot to the left, so we can write theta double dot equal same, it will be B times theta dot minus, because I will take it to the next side or the other side, plus K T times I plus torque load divided by the I value. So we have 2 equations here, and we will use the simulink to solve these 2 equations. Now I will go to a new file. I will choose the simulink again, blank model again. I will open now the library. We will assume that we have the value of R, A, Ke, all of the constants. So you have to decide, you want to use the constant as a constant like this, or the gain inside the gain. For me, I prefer the gain. More professional than the constants, but it's okay. For the constants, it's okay also. So we need 6 gains, or maybe less, I don't know, I will see. Ctrl C, Ctrl V, Ctrl V, Ctrl V, Ctrl V. Okay. Let me start for the first equation. Let me design the first system or first equation. This one, di over dt equal ra I. So we need the I first. Regarding I don't have the value. Assume it's just a constant. Double click here and change it to I. Don't worry, I will do something at the end. And we need minus ra, so I will take a gain like this, and this gain, let's say that it is minus ra, but remember that the ra should be defined on the workspace. Defined in the workspace. Connect I to the ra. We need minus ke theta dot. Again, I don't know the value of theta dot. Ctrl C, Ctrl V. Assume that it's just a constant. Double click here, write theta dot like this. Okay, and we need also the gain. Say the gain, it is minus ke. Okay, double click here, write minus ke E. Okay, connect theta dot to the KE. We need VA. VA is just a constant, so Control C, Control V, take it as a constant, but change it to VA. VA should be known. Double click again, VA. I will tell you later how we can define them in the workspace using a script or manually. I will use the script file. Okay, so we need this one, this term, and this term, and this is the third term. Now we have to add them together and then divide them by LA. So we need the divider. We will go to say that to the math operations. From the math operations, this is the divider. In this divider we have just two inputs. We can change them to 3 inputs and say that we have to so I'm sorry, not divider here, I cancel, I will use it later. We want to add them together first, so I will go and take the add. So this signal plus this one, so we have here just 2 signs. We'll use 3 signs like this, and you can resize the object like this if you wish. Now connect this one to here, connect this one to here, connect this one to here. Like this. Okay, now the signal come from here. It should be multiplied or divided by LA. So now we need the divider. So this one should be connected to the multiplication, and we need here the LA. It is a constant. Control C, Control V to copy this constant. Okay, connect this one to division. So now I'll see this one. It is minus RAI minus KE theta dot plus VA divided by LA, not VA. So let me change it to LA, and LA should be defined in the workspace using a script or manually. Now this signal come from here as by logic it should be the value of as you see here, it is the value of di over dt. So this is di over dt. One integration, we will get the current. So we have to say that integrate it to get the current from this one. So I will go to commonly used functions or the math function, continuous functions, and find the integration. This is the integrator. Okay, connected to this one. You can double click here and say that this is di over dt to remind yourself. Now this is the value come from here. It should be the I. It should be the I value. How we can show the I value? You can show it using scope. So let me go to sinks. Take a scope like this. Connect. Okay. Double click here to write the name. Say this is I. Just to remind yourself, this is I. Good. Okay. Now next step, as you see here, we have LA, VA, KE, RA should be defined in the workspace. Theta dot. What is the value of theta dot? I don't know. What is the value of I? I don't know, but we can take the I signal from here to here. So let me delete the I. Okay. And as I told you before, it's more professional to take the gain to here and right click on it, flip it like this. Now control, click on this line, connect this one and take it back to here. Take it back to here. Just to remind yourself, this is I, and this is should be what? Double click here. It is minus RAI, but you can keep it like this, never mind. Okay, next step. Regarding theta dot, we have to write the other equation. Theta dot double dot equal. We need the B times theta dot. So we need the b, say that it is just a gain. This gain is minus b. Okay, we need the theta dot, say that this is theta dot. Let me Ctrl C, Ctrl V, take it. We can use the same, but I will make it like this. Okay, so this is minus b theta dot. We need kti. I will use the gain also. We have the I value from here. We can connect it directly. So let me move this one to here and this one to here, and take the gain to here. Right click, flip it. Okay, connect the I, because I know that this is I. Okay, this is I, and this one should be kt. Remember that the kt should be defined in the workspace. We need the other here. Ctrl C, Ctrl V, take it like this, just to I don't want to forget. So connect this one to here, like this, and this one should be here, and the last term here, it is the TL. It is just a constant, so we can Ctrl C, Ctrl V, copy paste this constant to here, and connect it like this. Okay, now this should be the load, torque load, TL capital or small, doesn't matter, but it should be defined in the workspace. So I see TL plus KTI, this is KTI, and we here minus b theta dot. Okay, divided by I. So we need the divider, Ctrl C, Ctrl V. We can use it like this. So this, the sum of these divided by the I. I is just a constant, so Ctrl C, Ctrl V. Do it like this, connect like this, and this should be I. Should be I, and the I should be none. Like this, not the I small, it should be I capital, because the I small, it is the current. Okay, so this is done. Now okay, now let's suppose that the signal come from here. It is theta double dot. As you know, this is here, it is theta double dot. Integrate it to get the theta dot, integrate again to get the theta. So we need two integrations. Let me do it now using the integrator. We can copy this integrator, Ctrl C, Ctrl V, connect the integrator, double click, initial condition 0, and Ctrl C, Ctrl V again, like this. I see this one should be d theta. This one should be the second derivative. Actually, it is d2 theta, or theta double dot, theta double dot. Here it should be as example theta dot, and the value here come as a theta. Ctrl C, Ctrl V. We can connect it like this. This one should be, now it is the theta value. Now I'll see here regarding KTI, we take the I from here. What about the theta? This theta and this theta. Let me remove this theta first. Remove the bus. Where is the theta? Here. Take a bus from here directly to here. Keep the TL like this. And it's more professional, as I told you. Let me remove this bus again and this bus again. Take the gain minus B, right click, flip it like this, and take the theta times minus b like this. Actually, I like to make it more simple. I will delete this bus. I will choose move the TL, sorry, here like this, and this one like this, and double click here. You can write this is what the term is here, but double click here, it will give you the theta. As you see, this is theta minus b times theta, come to here, TL come to here, and I kt come to here, add them all, then divide them by L. It will give you theta dot. Integrate first, second integration to get theta. And this is the scope to show you the values. Now, let me delete this one, no need for this one. What about this theta? Same thing, theta dot. We need the theta dot. I think I did a mistake. Because this one should not be theta here. It should be theta dot. So remove this from here. This is the theta dot, take it from here to here. Now it's okay. What about this theta dot here? Here I will again, we can take from this bus to here. It is the theta dot. Double click here. It should be minus b theta dot. No, we can't take it from here. I'm sorry, we need the theta dot. In this case, we can connect from this side to this side, as you see here, like this. Now this is theta dot, and here theta dot. Okay, never mind. So this is theta dot, come to minus b, so minus b times theta dot come to here, and here theta dot come back to here directly. Now everything is okay, but the last thing we have to do is we should define the constant using a script file, or manually, it's up to you. So we can go to MATLAB. Let me go to the MATLAB here, open new script. We have to start from CLC, clear workspace, close all figures, and then we can write kt equal ke equal kt ke equal. We need the LA value. We have LA here. No, we don't have. We have LA. Where is the LA? Yes, this one. LA equal. We need the RA equal. We need the I, which is IK, IL and IL and plus IM. Anyway, it's I, should be defined by the user. And also we need the B. 1 2 3 4 5 6. We need also the voltage, the applied voltage VA. The applied voltage VA. Okay, say that the KT it is 100. Say that the KE 100 also. Say that the LA 1000. Say that the RA 1000. The I inertia, say that 200. I don't know exactly what should be. Regarding B, this is damping, should be, as example, say 0.5, and VA, the voltage, say that 220 volt. Save this file. Okay, then run the file, add to path. See, I'm sure that we have the B value, I value, KE, KT, LA, RA, VA. Now we can go back to the simulink, save it again. Now run the simulink. I'm waiting, we have a mistake here. What this mistake? TL capital. Okay, delete the errors. Again, let me go back to the script. We don't have KL, we have KT and KE. We have KT here and KE here. TL, the torque load, not defined. The torque not defined. Say that TL capital, I think, equal to, say that 1000 Newton meter, like this. So 1, 2, 3, 4, 5, 6, 7, 8, sorry. So we have 8 constants. Very good. Run the program again, go back to here, save, run the simulink again. We have warning here. What this warning is, run again. No, it's okay, working. Let me check here. We have yes, this is the current I, and this is the theta. If you wish to show instead of theta the speed, theta dot, we can add another scope, Ctrl C, Ctrl V, like this, and connect the theta dot from here, control from here to here. Double click here to show that this is the theta dot. If you want to show them in one scope, delete this scope, delete this scope, come to this scope, double click. You can go to view, you can go to configuration, say that we have three outputs, input ports. I want them all in one by one, like this. We can connect the scope like this, connect this one to here and connect this one to here. Okay, run again, double click on the scope. As you see, I'm showing them all in one graph. If you want to split the graphs in 3 graphs, we can again go back to the here simulation, sorry, view, configuration, the layout, say that we want 3 by 1 or 1 3 by 1, like this. Good. Now view legend, it will show you the values. See, this is the theta dot, theta, and I, the current. What if you want to show them in as a one input? So let me delete this one, delete this one, delete this one, go back to the here, go to view, configuration, see that just one input. We have 3 signals in one input, as a one input. How can I take 3 signals to a scope in one input port? We have to go to tools, library, go to commonly used. We have dmux and we have mux. We have mux. Now just double click on this mux. So a number of inputs, say that 3. I see, like this. Connect this one to here. So control, connect the current. This is the theta, and this is the theta dot. And now we can connect it to the scope. Now we are mixing or merging all of the 3 signals in one signal, and come to the scope, save it, run on the scope, double click. See, we have 3 figures. Now here we can go to view, configuration, layout. We can select 3 by 1 again, like this. But in this case we have 3 figures, but the input in one figure, the I, theta L, theta and theta dot in one figure. So we can go to view again, configuration, and say that the layout 1 by 1, apply, like this, because we selected the 3 signals to be merged in one signal, and we decided that we have just one input, Now if you want to take it to the workspace, as I told you, we can use go to the library, and you can go and select one of the sinks. You can take it, say that sim out. You can also, if you wish, you can display some value, max, min, whatever, okay, or average. Okay, say that this is the average of the current. Okay, this is sim out. Let me take all of them. I will show you. Let me take all of them to the sim out. Say that sim out, keep the name sim out, never mind, and say that I want to find the maximum current or average current. It's up to you. So I will connect it to the max. I search for the max, enter here. The MATLAB is searching now. Okay, this is min max. Double click, don't take the min option, max option. Now connect this one to here and connect this one to here. Save, run. See, the maximum current is minus 3.56. You know that the minus here is just direction. Sim out, it contains the theta dot and the current, and the scope, it will show all of them. Okay, let me show you the sim out. Here it is the out. See, sim out. In the sim out we have the time, data number 1 which is the current, data number 2 which is the theta, and data 3 it is the theta dot, the motor speed. So you can take them to Excel sheet, do some analysis, do what you want. This is how we can use the simulink to solve mechanical engineering systems or any type of system, any type of equations. Thank you so much. I hope that everything clear. Thank you so much for watching this video.